In problem number 2, we're asked to consider the decay from gold to mercury via gamma radiation. In this decay, we observe 3 different gamma rays of different energies, and we speculate that the different energy levels are from the various excited states of the mercury, where we expect the energy of the first 2 excited states to be equal to the total energy of that third state. And so we expect that the energy of these first 2 gamma rays should add up to the energy of the third gamma ray. However, when we naively add those together, that's not exactly what we get, and we end up with some numbers that don't quite agree. However, we can include the nuclear recoil in order to resolve this a little bit. The total energy of the actual collision is going to be the energy of the gamma ray plus the kinetic energy of the mercury. And we know that the recoil energy is going to be fairly small, and we know that it should be something in the keV range, since that's the energy of the photon. And we know that the mass of Mercury is much bigger than that, so we can treat the kinetic energy non-relativistically. And so I've said that the kinetic energy is just the momentum squared divided by 2 times the mass. We know that the total momentum carried off by the Mercury is going to be the same as the momentum carried by the photon, which we can get directly from the Einstein relation here. And altogether, we end up with the total energy is the original gamma ray energy plus this correction factor for the kinetic energy. The mass of Mercury, as stated earlier, is pretty large. It's almost 200,000 keV, so it's going to be pretty small compared to this gamma ray. And indeed, when we do those calculations, we see that for each of these gamma rays, this correction term is pretty small, so about 6 orders of magnitude smaller than the actual energy. But nonetheless, when we add on those corrections and take the difference, we now see that the difference in the energies is exactly 0, at least up to the uncertainty given to us originally, and therefore the problem is resolved.